Hello friends, today we will do quadratic equations. Usually this topic comes for 3 marks. After this you have a topic of quadratic equations word problems. So there also this fundamentals that you will learn here will be useful. Let us write the general form of a quadratic equation, which is ax square plus bx plus c is equal to 0, and a should not be 0. Of course, in our syllabus a, b, c will also be real numbers. So a, b, c belong to real numbers, and a will not be 0, because else this quadratic will no longer exist, as the first term will become 0. Let us take advantage of a being not 0. Let us say we multiply both sides by 4a. Now you must be thinking, why only 4a? So let's wait for a moment. Let's multiply with 4a throughout. So 4a into ax square will become 4a square x square plus 4abx plus 4ac is equal to 0. Therefore, the advantage is the first term looks like a perfect square, 2ax the whole square, plus the second term can be written as 2 into 2ax into b, and this term is looking completely different than the rest of them. Let us say we take that term on the right hand side as minus 4ac. The middle term 2 into 2ax into b is assuring you that this is possible to form a perfect square if you have b square here, as 2x the whole square is already here. So we can write 2x the whole square plus 2 into 2ax into b. Let us add b square on the left hand side, so we will have to also add b square on the right hand side, and minus 4ac is kept as it is. This has led to the formation of a perfect square of 2ax plus b whole square is equal to b square minus 4ac. Let us take square root on both sides. So it becomes 2ax plus b is equal to, when you take plus or minus square root, take both the roots, take plus or minus, root b square minus 4ac. Our aim is to get x, so first take b on the other side. So we get 2ax is equal to, let us take b on the other side, it will become minus b plus or minus root of b square minus 4ac. As we want x, let us divide by 2a. So x is equal to minus b plus or minus root of b square minus 4ac upon 2a. We getting x means we have factorized the given quadratic equation. This formula is called as Shreedharacharya's formula. Some books also write SHREE, Shreedharacharya's formula, invented by an Indian mathematician. Let us factorize, or after factorizing, let us write this two answers, because if you separate plus or minus it will lead to two answers. Let us write this as minus b plus root of b square minus 4ac upon 2a, and let us rewrite another root as minus b minus root of b square minus 4ac upon 2a. Both from here only, एक बार plus, one other time we have taken minus. Let us say we denote one of the root with alpha and another with beta. So you must be wondering ये तो x है. Yes, x is only 2 times written as, once as alpha and another time as beta. We can observe some interesting conclusions here. Let us say a student would have added both the roots. Let us say we add both the roots. Now because the denominator is same, we can add the numerators. So minus b plus root of b square minus 4ac minus b minus root of b square minus 4ac. See, we are adding both the roots. These two terms get cancelled. So this becomes a minus b is minus 2b upon 2a, which is minus b upon a. So we can understand that sum of roots, which means alpha plus beta, is equal to minus b upon a. Let us now try multiplying alpha and beta. Alpha was minus b plus root of b square minus 4ac upon 2a into minus b minus root of b square minus 4ac upon 2a. This is a plus b, a minus b form. So the result is a square minus b square. Root square will lead to only b square minus 4ac left out here. We will not square it, as root we have not written, upon 2a into 2a is 4a square, as they are multiplying, is equal to positive b square minus b square, minus of minus is plus 4ac upon 4a square. B square can get cancelled out. This becomes equal to 4ac upon 4a square, which is equal to c upon a, as we can cancel out 4 with 4 and a with one of the a. So this answer that we have got was of alpha and beta product form में. So we can even call this as product of roots is c by a. So sum of roots we have got minus b upon a. Sum of roots from earlier part was minus b upon a. Now let us reconsider our question. It is ax square plus bx plus c equal to 0. Because it was said that a is not 0, let us say we divide by a on both sides. Because it is a non-zero quantity, so you can divide. Therefore x square plus b upon a into x plus c upon a will remain. This can be written as x square minus of minus b upon a into x plus c upon a is equal to 0. But a while back we have written that minus b upon a acts as sum of roots. Let us say we denote the sum with capital F, S, and let us say we denote the product of roots with capital P, just to make it shorter. So sum of roots is minus b upon a. So this bracket will be written as S, and this c upon a can be written as P. We conclude therefore x square minus sx plus p is equal to 0. So any quadratic equation can be written in the form of x square minus sx plus p equal to 0, where s stands for sum of roots and p stands for product of roots. Let us take an example. To understand what we are trying to say. Say we have a question, say like this. The question is form a quadratic equation whose number 1 roots are 2 by 3 and 1 by 2. So this is like alpha and this is like beta. So in the first question, you want to form the quadratic equation. So let quadratic equation be x square, we derived it fully now, x square minus sx plus a p is equal to 0. Therefore x square minus s means sum of roots, so we will write sum of roots here will be 2 by 3 plus 1 by 2 bracket closed into x plus 2 by 3 into 1 by 2 product of roots equal to 0. Therefore x square minus, let's LCM, 2 2s are 4 plus 3, shall I write directly 7? 2 2s are 4 plus 3, 7 upon 3 2s are 6 into x plus 2 upon 6 is equal to 0. You could have cut 2 here, let's say, because 6 is getting formed here and here also we have not cut. Let's multiply by 6, so it becomes 6x square minus 7x plus 2 is equal to 0. What have we done? We have multiplied throughout by 6 is your required answer. So if roots are given and you want to form the quadratic equation, you can learn x square minus sx plus p equal to 0. We have seen the derivation of it, so now by understanding you can try learning it. Let's take one more question. One of the root is 2 root 3 plus 2. Now we are not provided with another root. Whenever the root is given in the form of a rational and an irrational number, always your other root will be the conjugate of this root. When we say conjugate, it is our duty to first, let's write in the form of a rational and then an irrational number. So 2 plus 2 root 3, order is interchanged, written in opposite way, and now the other root will be 2 minus 2 root 3. So one root is 2 plus 2 root 3, other root is 2. This is how you will take conjugate. Let us begin with the second part. So our quadratic equation is x square minus sx plus p is equal to 0. Therefore x square minus s means sum of roots. So the first root was 2 plus 2 root 3 plus 2 minus 2 root 3 into x plus product will be 2 plus 2 root 3 into 2 minus 2 root 3, product is written, is equal to 0, is equal to 0. Therefore x square minus this 2 root 3 and this 2 root 3 will internally cut, so 2 plus 2 will become 4x, x is there outside, while here it is a plus b, a minus b, so 2 square is 4 minus 2 root 3 square will be 4 into 3 is 12 is equal to 0. Therefore x square minus 4x, 4 minus 12 is minus 8, is equal to 0 is your required answer. I hope you have got this. Let us continue and let us understand what is the advantage of knowing the roots of quadratic equation. What is the advantage? What does root actually do? Root actually satisfies the equation, that's it. So if it is said alpha is root of ax square plus bx plus c equal to 0, then in place of x you can substitute alpha and still equality with 0 is maintained. So this implies a alpha square plus b alpha plus c is equal to 0. Let us take an example to understand this better. Say we have, okay, let's take this question. Let me take this question. Question is, if 2 upon 3 is a root of the equation kx square minus x minus 2 equal to 0, find the value of k. Now if 2 upon 3 is a root, it means that this can be inputted in place of x and equality with 0 is maintained. So our first step can be, let us write the equation kx square minus x minus 2 equal to 0. Since 2 upon 3 is a root, therefore k into 2 upon 3 whole square minus 2 upon 3 minus 2 is equal to 0. So where you see x, you will put 2 upon 3. This can be now written as 4 upon 9 k minus 2 upon 3 minus 2 is equal to 0. We can multiply by 9. We can multiply by 9. If you do that, you will be able to, LCM is 9. So we get 4k minus 3 3s are 9, 2 3s are 6 minus 2 9s are 18 is equal to 0. Therefore 4k minus 24 equal to 0. We get 4k is equal to 24. We can divide by 4. If you can divide by 4, you will get k equal to 6. So whenever you have one of the root provided, what you can do is you can substitute that in your x position and continue equating to 0 and get k. Hope you have understood this. Let's take one more. Let's take one more question. This you can try. I'll put the question. This we can solve faster. Question is, if 1 is a root to both the quadratic equations, but here x is not there, the variable in the question is y, then find the value of a into b. So you can substitute 1 in place of y here and continue equating to 0 and get a. In the second one, you can put y as 1, equate to 0, get b, and then later multiply a and b and get the answer. As I had said, we will do this one faster. Let us substitute 1 in place of y. So a plus a, as y is 1, plus 3 equal to 0. Therefore 2a plus 3 is equal to 0. 2a is equal to minus 3. A equal to minus 3 upon 2. Let us in the other part here put 1 and 1 plus b equal to 0. So b equal to 2 will become on the other side minus 2. Now what do we want? We want ab value. So ab will be minus 3 upon 2 into minus 2, which is 3. I hope you have got this one also. That was easy. Great. Let's continue. Quadratic equation is given. We can multiply 6 with minus 2. So product is minus 12 and the middle term is minus root 2. Middle term is minus root 2. The factors we can manage is minus 3 root 2 and 2 root 2. देखो √2 तो दोनों में लिखना ही था, एंड देन यू हैड टू अकॉर्डिंगली चूज द राइट नंबर्स. Addition of them is minus √2, the product is minus 12. Therefore we get 6x square minus 3 root 2x plus 2 root 2x minus 2 is equal to 0. 6 can be thought of as 3 into 2, which is 3 into √2 into √2, right? That's why here in the first two terms we will not stop at taking 3 common. We will take 3 root 2 x तो है ही common. X minus what will remain? √2 will remain, right? One of the √2's will remain. So √2x minus 1 plus 2 is common, and you again get √2x minus 1 equal to 0. Therefore 3 root 2x plus 2 into √2x minus 1 is equal to 0. We have factorized, but we want to get x. To get x, we can say 3 root 2x plus 2 is equal to 0, or root 2x minus 1 is equal to 0. This gives you x is equal to minus 2 upon 3 root 2, or x is equal to 1 upon √2. These are the roots of your quadratic equations. If you want, you can rationalize it. This can be written as, we can multiply and divide by √2, जैसे 9th में करते थे. You were rationalizing the denominator. So 1 by √2 into √2 by √2. So x becomes equal to minus 2 root 2 upon 3 into 2, or x is equal to √2 upon 2. That's it. This is your answer. You can cancel out one of the 2's. Or you could have just stopped here. That was fine. These level of problems were easy. I think they were already known to you. Let us take something different. Let us say the question is again solve. Solve means you have to get x. Okay, let me write here. The question is solve. Solve means you have to find x. So the first step looks easy. We can do taking squares on both sides. Taking squares. So this becomes 2x minus 3 the whole square is equal to 2x square minus 2x plus 21. Therefore 4x square minus 12x plus 9 is equal to 2x square minus 2x plus 21. This is 2ab term that will become minus 12x. Let's bring all the terms on the left hand side. So it becomes 4x square minus 12x plus 9 minus 2x square plus 2x minus 21 equal to 0. Therefore 2x square minus 10x, 9 minus 21 is minus 12, is equal to 0. All are even numbers. We can divide by 2. X square minus 5x minus 6 equal to 0. Last term is minus 6 and the middle term is minus 5. So correct factors will be minus 6 and 1. Let's continue factorizing. So it becomes x square minus 6x plus x minus 6 equal to 0. Therefore x minus 6 plus 1 x minus 6 is equal to 0. Therefore x minus 6 into x plus 1 is equal to 0. Therefore x minus 6 equal to 0 or x plus 1 is equal to 0. Therefore x is equal to 6 or x is equal to minus 1. So we conclude in this problem that we have just picked up, we can conclude that the answer that we have got for x is 6 or x is equal to minus 1. Now if you leave the answer in this way, then you may lose 1 mark, because when you substitute x is equal to minus 1 inside the left hand side part, you will get a negative answer. And if a function or if an expression is already square rooted, its answer will always be taken as positive. So when you put x as minus 1, you will get minus 5. That is not acceptable. So we will write, since x is equal to minus 1 is not possible, therefore x is equal to 6. X is equal to 6. This is the only answer and not x equal to minus 1. Now some students may have a query that whenever we take square root, it has always been taught to take plus or minus, right? So just for your understanding, you can note down, if x square is equal to 25, then it implies that x is equal to plus or minus 5. But if the question is x is equal to root 25, already it starts from here. The question begins from here. Then there will be only one root, that is x equal to 5. That is what is happening here. That's why we rejected minus 1. Let us take one more question. Let us take more question. We'll try taking up some more examples. Let's say we have a question like x raised to 2 by 3 plus x raised to 1 by 3 minus 2 equal to 0. Again, you have to solve. By 3 looks common, so this can be written by us as x raised to 1 by 3 square. 1 into 2 will again imply 2, plus x raised to 1 upon 3 minus 2 is equal to 0. This has given you now an idea that if you assume x raised to 1 upon 3 say as a, then our question will become a quadratic in a square plus a minus 2 equal to 0. This we can factorize. By splitting the middle term. So correct factors will be 2 and minus 1. So this becomes a square plus 2a minus a minus 2 equal to 0, which gives you a plus 2 minus 1 common, a plus 2 is equal to 0. Therefore a minus 1, a plus 2 is equal to 0. On separating it, we will get therefore a minus 1 is equal to 0 or a plus 2 is equal to 0. Therefore a equal to 1 or a equal to minus 2. Let us write resubstituting value of a, and we will get x raised to 1 upon 3 is equal to 1 or x raised to 1 upon 3 equal to minus 2. Let us take cube on both sides. Take cube on both sides of both equations. So x will become 1 cube is 1 only, or When you cube it, you will get x equal to minus 2 cube is minus 8. Both answers are acceptable. So the first step was important of realizing that we can write it as x raised to 1 by 3 whole square. Let's take one or two similar examples. If required, we will not solve them fully. If it's okay, if you understand it, then we can just take the main points and then you can draw on your own. Let's say this is the question. So 4 raised to 1 plus x, again you have 4 raised to 1 minus x, so 4 is looking as a common element. We can't take 4 directly out, but in 9th we had a topic called indices, so we can write this as 4 raised to 1 into again 4 raised to x plus 4 raised to 1 into 4 raised to minus x is equal to 10. Therefore 4 into 4 raised to x plus 4 upon 4 raised to x. If you want to remove negative power, you can take in reciprocal, it will look positive. And now you have got an idea that let 4 raised to x be treated as a, and this will now become, okay, let me finish it. I had told I will only give hint, so hint is over. Let's complete it. So 4a plus 4 upon a is equal to 10. So this gives us, on multiplying by a, 4a square plus 4 is equal to 10a. We can bring 10a on the left hand side, so it will become a quadratic in a. We can also divide by 2 as all numbers are even. So 2a square minus 5a plus 2 is equal to 0. 2 into 2 is 4 and the middle term is minus 5. Factors will be minus 4 minus 1. Therefore 2a square minus 4a minus a plus 2 is equal to 0. 2a common, a minus 2 minus 1 common, a minus 2 is equal to 0. Therefore we obtain 2a minus 1 into a minus 2 is equal to 0. Therefore 2a minus 1 is 0. So shall I write a is equal to 1 upon 2 or a is equal to 2? But a is 4 raised to x and 1 upon 2 can be written as 2 raised to minus 1, or again 4 raised to x is equal to 2. This can be thought of as 2 raised to 1, but there is no match as this. It is 4 here. We know 4 can be written as 2 square. So 2 square raised to x is equal to 2 raised to minus 1. This can be written as, therefore 2 raised to 2x is equal to 2 raised to minus 1. Therefore because the bases are same, powers can be equated. So we obtain x is equal to minus 1 upon 2. And here similarly we will get 2 raised to 2x is equal to 2 raised to 1. Therefore again bases are same, powers can be equated. So 2x is 1, therefore x is equal to 1 upon 2. Both answers are acceptable, as even if you re-put them in the question, even if you re-put this value in the question, it will satisfy the RHS and give you 10 again. If you want, you can try it. Right. Let us take one more. Let us take one more question. Say we take x plus 1, x plus 2, x plus 3, x plus 4 all multiplying plus 1 equal to 0. Question is again solve. Now see, if you are going to multiply, you will get x into x into x into x, that will become x raised to 4. Then the next term x cube So there will be some coefficients here, and then it will become a very complicated equation. So the trick here is that observe the coefficient or the constant, not the coefficient. Observe the constant, it is 1 here and 4 here. So 1 plus 4 is equal to, and look at the other constants, 2 plus 3. So it is advisable to rearrange the terms and write x plus 1 into x plus 4 into x plus 2 into x plus 3 plus 1 is equal to 0. Let us multiply the first two terms. So it becomes x square plus 5x plus 4. You can verify it. X into 4 is 4x plus 1 into x is x. So total is 5x and 1 4s are 4. Similarly here you get x square plus 3x plus 2x is 5x plus 2 3s are 6, bracket closed, plus 1 equal to 0. Clearly x square plus 5x looks similar. That was the intention of grouping the terms earlier. So we can now write let x square plus 5x is equal to say a. So we get a plus 4 into a plus 6 plus 1 is equal to 0. Okay, I'm not leaving it here. Let's try completing it. I will do it a little faster. A into 6 is 6a plus 4a will be 10a. 4 6 are 24 and 1 is 25 equal to 0. So either you can factorize by splitting the middle term, or you can realize that this is nothing but a plus 5 the whole square, as this was a perfect square and a square is also a perfect square. So you can check 2ab 10a ho raha hai. So on taking square root, a plus 5 equal to 0. So a is equal to minus 5. But on resubstituting, you will get x square plus 5x plus 5, x square plus 5x is equal to minus 5. Therefore x square plus 5x plus 5 is equal to 0. Right? Okay. So we are getting a quadratic which is not looking factorizable. Now this is yet not taught, but in future it will be taught. There is something called as discriminant, and that is usually denoted by a triangle. We call it as delta, and it is given by b square minus 4ac. So let's evaluate it in this case. So we will compare the given quadratic with ax square plus bx plus c equal to 0. Therefore a is 1, b is 5, coefficient of x, and constant c is 5. Let us put it in discriminant. So b square is 5 square is 25 minus 4 into 1 into 5 is 25 minus 20 is 5. So the roots of this quadratic equation are x is equal to minus b plus or minus root of b square minus 4ac upon 2a is equal to minus 5, as b is 5, plus or minus root of 5, as we have got it above, upon 2a, a is 1. So this is it. So answer for x is, therefore x is equal to minus 5 plus root 5 upon 2, or x is equal to minus 5 minus root 5 upon 2. Right.